Here I have problem number 11 from the 2023 AMC 12A, which is a 25 question multiple choice qualifying exam for the AIME, which is the American Invitational Mathematics exam. This is part of some competition math. Now the question here is asking, what is the degree measure of the acute angle formed by the lines with slopes 2 and 1/3? And now it's time for a little moment of vulnerability, okay? And this is where I share with you a story that's quite embarrassing of my performance on the AMC. And believe it or not, the way I tried to solve this problem was like this. If you have a line with slope 2, then of course it looks like this. You have a line of slope 1/3, which looks like this. And of course the angle formed by a slope of 2 is going to be arctan of, arctan of 2. Arctan of 2. So, arctan of 2. Alright? And the slope of 1/3 angle is going to be the arctan of 1/3. Because if the tangent is going to be the slope of the radius from the unit circle, then the arctan is the angle formed by that line. And so, now what I can do is I can approximate arctan of 2 and arctan of 1/3 using Taylor's series from calculus. So I have this crazy sigma on my paper while I'm solving this problem. So you have 2 to the 2n plus 1 over 2n plus 1. And you subtract from that another crazy sum. And I would try and estimate that on paper and then try and find the answer from this. Now, please do not do this, all right? Because this is a terrible idea. And then what I realized as well was that the answers are in degrees. And this is going to give you an answer in radians. So I'd have to multiply by a conversion factor to get my answer. And so I eventually decide to just ballpark it and guess one of these options. Hint, it was B, and the answer is not B. So let's actually go about the real way to do this, which I actually decided to do near the end of the competition, and I still somehow managed to put down the wrong answer, even though this method is the one I wanted to use, and I love it. All right, we're going to use vectors, all right? I'm going to say let V be a vector which has the slope 3, 1, or has the coordinates 3, 1. So now, that means the rise is 1 and the run is 3, so the slope, of course, is going to be 1/3. And I'm going to draw a new kind of graph over here so we can have a good idea of what these things look like this. Okay, and we're going to let u, all right, the u vector be equal to 1, 2, where the rise is 2, the run is 1, so the slope is 2. So you can see here on the graph, this is our u vector, and then this is our v vector, okay? And the angle between them, we're going to call phi, okay? And so we got to find phi. Okay, so we got to find phi. All right, and the way we do this is using a fun little operation that's one of my favorites personally, called the dot product. And so let me remind you what the dot product of two vectors is. All right, if you take the dot product between two vectors, A and B, then what this is defined as geometrically is the signed magnitude. All right, and that's a weird term, so it's A and it's the signed magnitude of A's projection onto B. So that's a mouthful. So S just means signed magnitude, all right? And you multiply that by the magnitude of the vector B. And so visually, let me tell you what that looks like. So if you have a vector A like this, and you vector B in blue like this, then you're projecting A onto B to get this vector. You're taking its magnitude and you're multiplying it by the magnitude of B, and that's the dot product. Now, this is also equal to, coming from some derivations, the magnitude of A, all right, times the magnitude of B, times the cosine of theta. And now you might understand why I'm introducing this, because there's a theta, and theta is precisely the angle in between the two vectors. And so if we find phi, then that means that we have u dot v is equal to the magnitude of u. I'm actually going to write this out. So we have u dot v, right, dot v is equal to the magnitude of u times the magnitude of v, all right, multiplied by the cosine of our angle phi in between the vectors. Okay, now, if you don't know how to calculate the magnitude of a vector, I'll show you right now, all right? The magnitude of A, or a vector, let's just call it W because we're going to use A. I love using the different letters. And let's say that W has the coordinates in 2 dimensions of C and D. Then the magnitude is simply going to be the square root of c squared plus d squared. And where have you seen this before? Well, you've seen it in the Pythagorean theorem, and this is exactly what that is. Because if you have a vector, you can split it into a horizontal and vertical component, and by the Pythagorean theorem, you get the actual size of the segment, or the vector itself. All right? And this is also related to complex numbers and how you find the absolute values of certain complex numbers. I just love vectors. They're awesome. All right. Off with my tangent. You can also express a dot product of vectors algebraically by saying if you have a W vector, which is CD, and I'm going to actually express this in a different way. If you have the vector A as some n-dimensional vector with components A sub I, all right, so A1, A2, A3 for each dimension, and B vector is going to be vector B sub I, all right? If A and B are both of the same dimension, then the dot product of the two vectors A and B, all right, A dot B, is going to be the sum of the pairwise products of the components. And that's expressed as the sum, so sigma of I, and then AI, all right, A sub I, times B sub I. Now this looks scary, but I'll tell you right now that it's not that hard, all right? V dot U, or U dot V, will give you 1 times 3, all right? So let's just write that out. This is going to give you 1 times 3, and I'm actually going to color code them from the components. So U is 1, and V is 3, like this, 1 times 3. And we add that to 1 times 2, or 2 times 1 in this case. So 2 in green times 1. And this is going to give us 5. All right. Now, what is the magnitude of U? Well, magnitude of U is going to be, by this idea over here, it's going to be the square root of our components squared. So you have 1 squared plus 2 squared. So 1 squared plus 2 squared, which becomes 1 plus 4, which is equal to square root of 5. All right. And what's the magnitude of V? Well, the magnitude of V is going to be the same idea. We have 3 squared plus 1 squared. All right. And that's going to be equal to 9 plus 1, which is equal to the square root of 10. And so multiplying this together, we get that 5 is equal to, the product of these two is going to be root of 50, all right? So we have root of 50 times the cosine of our angle phi, okay? And now all we have to do is isolate for phi. So that means that cosine of phi is going to be equal to 5 over root 50 by dividing the root 50. And what is that? Well, root 50 is the same thing as saying the root of 25 times 2, right? And 25 is a perfect square, so you get 5 root 2. And that's awesome because we have a 5 on the numerator too. So we have 5 over 5 root 2. And of course, these 5's cancel out, and we're left with 1 over root 2, which should make you very happy because we know an angle that when you take its cosine is equal to 1 over root 2. Essentially, angle phi is equal to the arc cosine, okay, the inverse cosine of 1 over root 2. And that's going to be equal to pi over 4 radians. And pi over 4 radians, we know, to convert into degrees is just 45 degrees. And that's the answer. And in fact, that is the answer, or one of the answers that we're given over here. So the answer is 45. And I just love the vector approach to this because it's just so beautiful, right? Vectors are just such an awesome tool to use in mathematics regardless, and they're so important in so many different applications. Now, again, coming back to a little bit of vulnerability here, near the end of the exam, when I looked back at the problem, I did decide to do this problem using dot products because I did not want to just eyeball it. And I, for some reason, forgot that you can take root of 50 and split it into 5 root 2. And so I never was able to really simplify 5 over root 50. And so I still said, you know what, I'll just eyeball it as 37.5. So that is 0 points for me. Till next time.